So in our last video, we were looking at, what were we looking at? Yeah, so we had some terminology that we introduced, right? We're trying to get around to step 2 of hypothesis testing. The terminology we introduced was critical region, right? Or rejection region, critical region or rejection region. The rejection region or the critical region is the region under the Z distribution or T distribution for which you reject the null hypothesis. So it's either going to be an extreme right tail, an extreme left tail, or actually both tails, both extreme tails. So you got the left tail situation, the right tail situation, the two tail situation. So those are going to be your critical regions. What is the significance level? That was another term we threw out there. Well, that was called alpha, right? Significant level called alpha. It's actually the probability that your test statistic value that you calculate for your sample information is going to fall in the critical region when the null hypothesis is actually true. And finally, the critical value. The critical value or the critical values are those z-scores or t-scores that separate the rejection region or the critical region from the non-rejection region or the non-critical region. So that's the information we introduced last time. So this time, we want to get further. So we got that terminology behind us. We want to talk about how do you figure out if you have a two-tail situation, a right-tail situation, a left-tail situation. Yeah. So when you have an alternative hypothesis, remember alternative hypothesis is a hypothesis where you have like not something, so it doesn't involve equality, right? Does not involve equality. So one of your cases is when you have a greater than situation, right? A greater than situation, right? For example, if you have the mean is greater than a number, you're going to use a right-tailed test, right-tailed test. So that's one situation. What if you had your alternative where the mean is less than a number? The mean is less than a number, then you're going to use a left-tailed test. And then you could also have an alternative, third situation, where the mean is not equal to a number. In that case, you're going to use a two-tailed test. So 3 different situations. Important. So the second step of hypothesis testing, so the first step is actually identifying what the null and the alternative hypothesis are from the claim. The second step is going to be kind of 3 parts. The main part is part C, actually. Part C is the main part. But to get to part C, you're going to really have to go through parts A and B. So part A is where you first figure out, okay, which distribution am I using? Am I going to use Z or am I going to use T? So you're going to use Z. Going to use Z if you have the population standard deviation sigma, if it's assumed. So if there's some previous study that estimates the population standard deviation, you're going to use that population standard deviation. You'll use a Z distribution. What if you don't have population standard deviation? What if you have S, sample standard deviation? What if you have the sample standard deviation instead of the population standard deviation? You're going to use T. Important. So once you decide whether you're using Z or T, then you have to figure out how many tails you're going to do. Are you going to do a left tail? Are you going to do a right tail? Or are you going to do a two-tailed situation? And that's just what we talked about earlier, right? That's based on the alternative, right? So if you have a, what did we say earlier? If you have a greater than situation for your alternative, you have a right tailed. If you have a less than situation for your alternative, then you have a left tailed. And if you have a not equal to situation for your alternative, and you have a two-tailed. So that's what you're going to do. And then finally, you can use the Z table or the T table to figure out your critical Z-scores or T-scores. They're called critical values. So when you have two tails, you have to find 2 critical values, either a Z upper star, Z lower star, or T lower star and T upper star. And when you're doing a left-tail test, you only have to find a Z lower star or a T lower star. And when you're doing a right-tail test, you only have to find a Z upper star or a T upper star. Let me write or here so we're just clear about that. Or. It depends on whether you're using a Z or a T situation. Okay, so we're ready to do an exercise. So here's our exercises. Instructions are determine which distribution will be used, which tails will be tested, and find the critical value. So we're going to do that A, B, and C for step 2. So we're all about step 2. Here's the claim, our first problem. Average temperature in July is 88 degrees Fahrenheit. Average temperature in July is 88 degrees Fahrenheit. So let's actually, before we do step 2, we really need to do step 1. Identify the null and alternative hypothesis. Identify the null hypothesis, H0, and the alternative hypothesis, H1. Really, you need to do that first. So you got H0 with a colon and H1 with a colon. Now remember, this is going to be about mean or average of a population. So we're talking about the mean equals, always equality, right? The null hypothesis is always about equality. So this is going to be about the mean equals 88, right? So the average 88. Now it turns out that if you read the claim is actually involving equality, right? So the claim is the average is 88. So this is actually the claim. Right, that's the claim. So anytime the actual claim is the null hypothesis, then the alternative is a not equal to situation. A not equal to situation. So the mean is not 88. Now, we're ready to actually start step 2 now. Finally starting step 2. So essentially step 2 is finding the critical values, finding critical values. But we said there are several parts to this. There's like an A, a B, and the C. So part A, first of all, you want to determine which distribution you're using, right? Which distribution? So the big question is here, what are we going to use? Are we going to use a Z or a T? A Z or a T? So I'll write that here. Z or T distribution. Which one? Well, if you look at the situation here, we don't have the population standard deviation, right? We have the sample standard deviation right here, right? That's the sample standard deviation. So that means we're going to use T. So I'm going to scroll down and I'm going to get rid of that Z. We're just doing a T distribution. Okay, so that's the first thing. Second thing we got to figure out is how many tails. How many tails? Which tails? Are we doing a left, a right, or a two-tailed? Well, if you look at the alternative here, this tells us we're going to do two tails, right? Two tails. The alternative is not equal to, so we're going to do two tails, two tails. So finally, we're actually ready to find our T lower star and T upper star. So that's what we're all about. So we're going to find T lower star and T upper star. We got to find an upper star and a lower star because we have two tails. So if I draw a picture of my T distribution, let's draw a picture here. It's a lot like the Z distribution. It's bell-shaped, it has a 0 in the middle, and you have two tails. And remember what our significance level was. Our significance level here is 0.05, right? 0.05. So in total we have 0.05 area in the two tails. So right here and right here all together. The area in 2 tails is 0.05. Now, what are our degrees of freedom? Degrees of freedom. So we've talked about degrees of freedom before. Degrees of freedom are going to be 1 less than the sample size. So our sample size here was 15, if I can get to it. So I'm going to do 15 minus 1 to get my degrees of freedom. It's going to give me 14. So when I go into my t table, I'm going to look up area in 2 tails is 0.05, and look up degrees of freedom is 14, and that's going to give me a t upper star. That always gives me a positive. So your t table always gives you a positive t-score. So we're going to figure out what t upper star is. T upper star, and actually it's this number right here. This is your t upper star. It's separating this rejection region on the right, this blue rejection region on the right, from the non-rejection region in the middle. So here we're going to go. We're going to go into our table. We got area in 2 tails is 0.05, and degrees of freedom are 14. So here I go. I got area in 2 tails is 0.05. Degrees of freedom are 14. I match those up. And it looks like I get 2.145. 2.145. So it turns out your t-table is only going to ever give you a positive t-score. So what about the negative one over here? Well, it's easy to find the negative one. The negative one is just going to be the negative of that positive t-score you just found. So it's going to be t lower star is negative 2.145. And there we have it. Those are our 2 t critical values. T upper star, T lower star. That's how it's done.